Hi everybody, in this video we are going to discuss about how we can retrieve an element at a given position in a linked list. So the input for this operation will be the list in which we are going to retrieve and the position at which we are going to retrieve. For example, if the position is given as 4 and if this is the list, then the code should return 21, right? 21 is the element at the position, at the fourth position of the list. And if the position is not valid, for example, if the position is given as 0, since we are following human indexing, the nodes are numbered from 1, right? 1, 2, 3, 4 and so on. So if the value is 0 or negative values, then we should return -1, indicating that the position is not valid. Similarly, if the value is also, position value is also greater than 5, because there are only 5 nodes in this linked list, if the position value is greater than 5 also, then we have to return -1. That is the objective of this code. So what we can do is, the first step we can check whether the list is empty. In that case, if the position is anything, irrespective of the position, we should return -1, right? Otherwise, we have to have a pointer, temporary pointer, initialize that to the first node, and then we can have a counter equal to 1, right? Then we should be checking whether counter value is equal to the position. If it is equal to the position, then we can return the value of the data part of the node pointed by temp, right? Otherwise, what we should do, we should move the temp to the next node and increment the position, right? Then you will be checking whether the counter value is same as the position. If it is so, then we can return. Otherwise, do the same, you increment the counter and move the temporary pointer. Now counter is 3 and temp is pointing here. Position is 4, not equal. So again do the same thing. I will move here and increment the counter. Counter will become 4 and temp will be pointing here. Temp is equal to counter. So you will be returning 21. This is the logic that we are going to use. And the case when position is not valid, for example, if I give the position as 6, then what will happen? If the position is 6, still the counter value is not equal to the position. So I'll be incrementing the counter and moving the temp as well. And 5, right? I'll be here, and then still the counter value and the position are not same. So I'll be incrementing the counter. Counter will be 6, and my temp value will become null, right? Because the last node's next part is going to have null. That's what will be the content of null. In that case, I should not return, or I should not try to derefer the null pointer. I will get segmentation fault. So within the loop, we have to check if temp is null. When you are traversing, you should also check if temp is null, then you should return -1, right? So let us see the algorithm step by step. The first step is, as discussed, if the list is empty, then you will be returning -1. Otherwise, you will be coming to step number 2, where you will declare a temporary pointer temp and an integer counter, and you initialize the temporary pointer to point to the first node. That is, make it to head, make that to point to head, and counter also will be 1. And then while counter is less than position, you have to repeat step number 5 and 6. What does step 5 says? If temp is null, then you will be returning -1. Otherwise, you will be moving temp to the next node and increment the counter, and you will be returning the data part of the temp, right? It's better to check if temp is not equal to null here also, because I think if the value is 1 more than the node, we may get a segmentation fault. That we will check in the implementation and further discuss. So let us start the implementation and see. So here I'll be writing the retrieve function. So the retrieve function is going to return a integer, since the data is integer, and will take a list and then the position where we have to retrieve the element, right? So it's not required to pass it by address, because whatever changes we are going to make within retrieve need not get reflected. Okay, we are not going to make any changes in the list. So let it be passed by value, and let us follow the algorithm. The first step says if the list is empty, isn't it? Yeah. So you can check if is empty of L. Then we will be you cannot, in the algorithm we can tell is return -1, but when we think about the implementation, returning -1 may not be correct always, because we are going to return the data in the linked list. Okay, data is not assured always to be positive. It can also be negative values. So one of the data may be also negative. So we should have a new error flag, right? And initialize that to false. Actually we do not have a false in C as we discussed earlier. So you should give equal to 0. And let us move to the retrieve code, and here you will be telling retrieve did I give us 1 minute? Let me check the error flag name. Sorry, it's not locate error, it's going to be retrieve error flag. And whenever we are working with global error flags, global variables, we should be careful as usual. So let us first of all initialize. This is the function which will be making changes. So let us initialize that to false, and if it is empty, if the list is empty, then we have to set the error flag and then return -1. That's what we have to do. Equal to 1 and you return -1. This is what we are going to do for empty case. Otherwise what we are going to do, we are going to declare the temporary pointer, right? Let us declare a temporary pointer, and you have to declare a counter, right? Then you initialize the temp equal to head part of the list, right? And also counter equal to 1. Then you loop. When you are looping, what you will tell? When position is not equal to counter, right? If we have not reached the particular place, then you will be telling temp equal to temp next, and you will be telling counter plus plus. Okay, so you will be looping through till the position, that is the pointer, comes to the node which is at the position POS, right? And then after coming out also, we can better check whether temp is not equal to null, or if you simply tell if temp, that indicates that if temp not equal to null, because null is false. When you consider pointers, null is false and all other values are considered to be true. So if temp, then what we are going to do? We are going to return the return the data part of the temporary pointer. Otherwise what you can do is you can return -1. But one more thing we have to do in these cases, okay, I have to make the error flag also as true. Okay, so let me tell retrieve error flag equal to 1 and return -1, right? And one more condition is when we are moving inside this, when we are telling temp equal to temp next, here also we have to check if temp is equal to null, right? If temp is null, then we have to intimate, right? Retrieve error flag is equal to 1, and you should also return -1. Okay, fine. I have a doubt whether we have to have this if here, because we are checking it here, right? Okay, let it be. We will, when we are executing, we will comment this and also check, right? Hope the code is ready. Let us compile and check it. Yes, we can check the code. The main I have returned, I am calling the retrieve function. I am giving the position as 1 and I am checking if the retrieve error flag is set, then I am giving invalid position. Otherwise I am giving as element at the position. I am printing what is being returned by the retrieve function. Okay, so let us compile the code. There is no compilation error, and let us execute it. Now I have given the position as 1. So when you see the linked list, it contains 2, 10, 1, 5. There are actually 4 elements in the linked list. That's how we have inserted. When I ask for the element at the position 1, it is returning me the correct element. Let me give the position as 2 now. So when I give 2, I expect the code to print 10. Okay, so let us compile the code and give, yes, the element at the position is 10. And let us try 4. 4 means that should print the last element, because there are totally 4 elements. Yes, the last element is 5, that is getting printed. Let us try 5. When I am telling 5, compile and check. When I'm giving fine, it's giving us invalid position. Actually this check is not required. Coming out and checking whether temp is not equal to null is not required, because as soon as we change the temporary pointer, we are checking inside the loop. If it is null, then we are returning -1. Okay, that itself is sufficient for the code to execute correctly, right? So I'll be sharing the code in the GitHub. You can try out by yourself. Thank you.